Yo, what's up, everybody? Welcome back. Today we are working on our font renderer, and today's goal is to do some form of like proper rasterization. So, context is we are working on an image editor. We are trying to replace GIMP, right? And in order to do that, if I want to make a thumbnail for my videos, and I need to put draw an arrow and put like some text on it and say, "Doctors hate this one simple trick," right? Or like some fucking stupid YouTube shit. Um, in order to do that, we have to be able to put letters on the page, and we could use like a normal, font renderer like everyone else. We could use like Harfbuzz or something like that. But then it's not as fun, and then we can't say that we have no dependencies, right? It's more fun if we render the letters ourselves. And so that's what we've been working on for the past few days. Here is like kind of like the current state. We have the ability to render some letters. There's a few artifacts kind of left here, but we've managed to like extract glyphs for desired characters out of a TTF file and find the definitions of the curves that make them up. That's a bug because it was like halfway through a fucking render when I deleted it, or when I stopped the process, but for the most part, it's working pretty well. We have one bug to tackle where if the end of a contour ends on like a Bezier curve, we accidentally think that it's not a Bezier curve, so we have to fix that. But after that, I think the goal for today is going to be to fill in these things, and then maybe do some form of scaling to the correct width and height. Right now, we're kind of just working in whatever space we feel like. And then when we make the letters small, we'll probably find out that they look really bad, and we'll probably want to do some sort of form of like anti-aliasing or something. I don't really know what yet. So yeah, that's the plan. That's the plan. And I guess let's just jump in. So let's fix this case down here. This right here. So the way that these fonts are stored is kind of like this. So there are on curve and off curve points. Curves are kind of like a series of, or letters are a series of contours, where a contour is like kind of like any shape you can draw without picking up your mouse, essentially, right, or picking up the pen. So here, in this example, they go 0. Oopsies, fuck. Why would you make it so when I click it like undoes all the zooming I did? Okay, so we start at here, and then we go here. These are two on curve points. You can see them rendered with like little dark colored squares here. And then they have like some off curve points. And so it's like, well, what are the points if they're not on the curve? Well, they define Bezier curves. So you can kind of do something like this, where this Bezier curve is kind of defined with like an off curve point here that says like, take this line, and kind of draw lines between like every kind of like set of points along here. So like, all the way to the end, all the way to the end, you kind of like draw lines all the way across like this. I don't know, something like that. And it makes like a curve. And so you have this like control point off here. So that explains one off curve point, but sometimes they have like several in a row. And that's basically just saying like if I have on curve, off curve, that kind of defines like an implicit on curve point that's like halfway between them, like here. And what this is saying is like now we have like two Bezier curves. We have this curve, which is defined with like this control point, and then this curve, which is defined with like this control point. So we've kind of like broken this up. So we say like, okay, if we have two on curve points, that's just a line. And then if we have an off curve point, then we, as the second point, we have to draw a Bezier, and we have to like resolve what like the imaginary on curve point is between these things, right? Now what happens is when we wrap all the way around, we have like a special case to handle with like wrapping back to 0, and I'm pretty sure it's just that wrapping back to 0 case does not correctly handle the fact that it has to like resolve on curve and off curve points, and that should be pretty easy to fix. We just haven't done it yet. So how does this work? When we render something, we create a glyph segment iterator, and we iterate over each segment, and this thing spits out lines or Bezier curves, so it's going to be in here somewhere. And yeah, we have a fix me here. Factor out 3 points to resolve point logic. So that's kind of this, where we say what we get. We have point A, we have point B, we have point C, and we say if A and B are on curve, then it's a line. Otherwise, if B is on curve, then and A is off curve? What does that mean? This might be a bug. Here we're saying if B is on curve and A is off curve, what case is that? Can we see that here? So that's like 28 to 29 is, we'll call this like A, B. So this, I guess that's the case where we have like 27, A is off curve, to 28. Oh, because we've kind of already used 28 as part of a bezier from like 26, 27, 28. That was a bezier that we already drew. So when the second point is on curve, but the first point is off curve, we're like, we've already drawn that curve. So we have 28 to 29 is on curve. That's a line. Okay, got it. Right. So I guess we can just kind of say that we can just get all 3 points. I'm pretty sure that this get point will always be valid because he handles wraparound correctly now. So we should be able to be like, given point A, B, and C, we can probably do like ABC to curve. I think that makes sense. So this is going to be like A is going to be a point, B is going to be a point, and C is going to be a point. Is on off curve an in-file flag per point, or is it inferred somehow? Is there some maximum number of off-curve points between 2 on-curve points? Solving quadratics is simple. Solving quintics is analytically is impossible. So I think that every Bezier curve is a quadratic, and if you have like 5 off-curve points in a row, you kind of like implicitly resolve these into some on-curve points as well, right? So you kind of like bisect them, and you go like, there's an on-curve point here, here, and here. You know what I mean? And then this will kind of curve like this, and this will curve like this. And yeah, it is just like a flag in the file somewhere for each point. So I guess then we can kind of just take all of this logic and slap this in here. And this will return a Boolean so that we can say, no, this will return an optional curve, I guess. Yes. So what is our curve type? It's output, we called it. So this will return null to say, try again, please. But the rest of this is probably fine. And then here we can call ABC to curve, ABC. If this thing is a value, return val. Otherwise, we do nothing and continue on. That seems pretty reasonable to me. So let's just kind of like quickly run this and make sure that like everything still works. And make sure that like the things that are rendered are still somewhat sane. So where's like my A, B, C, D? Yeah, so nothing's changed, but the refactor didn't break anything, which is good. Because we did change a little bit of order of stuff. I guess kind of like, now we're going to kind of use ABC kind of no matter what here. And I guess we just don't return in here. So we just say like, if we are at the end of a contour, move to the next contour and like get ready to work there. But in terms of like us right now, we don't have to worry about that shit. Yeah, that seems reasonable. That seems like it might fix it. So let's go back to the letter S. And it looks like that fixed it, right? We used to have like this like kind of like shit on the bottom here, and it does seem like it's good. So let's just quickly like eyeball all of these letters. O is also better than it was before. I think that fixes our problem. G also had like the thing at the bottom before. Yeah, I think we're chilling. I think that fixed what I wanted. Not bad, not bad. All right. And the code is simpler now. Hell yeah. I love writing stuff myself, but font rendering seems like a huge task when you consider all the other things like right to left, Unicode, emoji, and probably a million things I don't know about. Yeah, but in my world, in my world, I kind of consider things that I don't do don't exist, right? So like one day, if I'm ever doing a right to left font, then I'll care. But the chances of me ever doing that are like essentially zero. So I just don't have to think about it, right? Same with like vertical fonts. And I think that like once we've done like half of the work, we'll kind of understand what would need to be done if we did ever care about those, right? Like if I were making software that were to be used by everybody in the world, then all of a sudden this becomes way harder, right? Because it's impossible for me to know how other people are going to use my software, and there's probably all these like edge cases that aren't gonna like manifest and be problems, right? But since I'm writing software for me and like my specific use cases, I don't have to care, right? Which kind of simplifies a lot. Um, yeah, which also allows us to like kind of learn about things without having to worry about them being perfect, which is also kind of nice, right? This, like, we can kind of go through this exercise, and then if in the real world I ever have to write software that will be used by everyone, I'll go, oh shit, this is a complex problem that has a lot of solutions that are varied for a lot of different groups of people, in which case then I will have to care and I will have to use some sort of library, right? But I'll have kind of like a good intuition about what that library does and the complexity of it, and I'll have like a better idea about when I should make that decision and when I shouldn't, if that makes sense. Um, yeah, yeah. Okay, git diff, git add dash u, git commit dash m, whip fix, um, fix bezier wraparound. Okay, let's do some form of masking. So I think what we want to do is when we render a character, we want to no longer just draw the outside of this bezier, but we kind of want to like fill some form of polygon. So here's what I'm thinking. We have some curve, some lines, right? We're going to go line by line and try to resolve at each line all of the places where something intersects us, right? So if we're drawing like the letter O, there will be some cases where we have like 0 intersections, some cases where we have 2, and some where we have 4, right? And for each line, I think that what we could do for now is we can just iterate every single curve in the letter. That's not super efficient, but it's good enough. Probably. I doubt that we're gonna have more than like 40 curves in anything, right? So it's probably fine. Right? It wouldn't be a problem until we get into like the thousands, would be my guess. Um we can probably just kind of say at each scan line, resolve the X positions for each curve, which we have now in our renderer. We have this like find Bezier T for Y, which allows us to, oh fuck. I did some off-screen fixes for this that made it a little bit nicer to work with. But I can deal with those. I'll merge that offline. It's fine. I refactored this find Bezier T for Y so it's a little more readable, but it's fine. It still works. Anyways, so what we can do is we know kind of where on the curve we are for each Y positions. We have like maybe 2 possible X positions for each Y. And we can just use this function to figure out where we are. And then for each line, we'll basically have like a bunch of dots, right, of where we intersect. And we can basically just like group by 2s, right? So we can say like this stuff is going to be white, this stuff is going to be white, this stuff is going to be white. And they should always be pairs. There should always be pairs. So how do we want to do that? Right now, the renderer doesn't really know about Bezier points. Maybe we want to keep it that way. Or sorry, doesn't know about like curves. Maybe we want to keep it that way. So maybe we can do like, maybe we don't want to do it that way. Renderer. We could do like render glyph. I'm going to do it externally for now. So let's say that we have some sort of canvas. Where maybe we'll call this like a rendered glyph. I guess we could just kind of abuse the renderer type. We kind of have this like canvas already inside. Yeah, we'll just use this. That's fine. It's a violation of abstraction, but we'll deal with that later. So I guess we're going to be like, give me all of the lines and curves in this thing, and we'll collect those into one place. That seems pretty reasonable to me. So we'll say that we have some like, this is going to be an array list of glyph segment iterator outputs. Okay, we're going to say defer curves dnit. And then instead of drawing right now, we'll literally just push these things into the curve list. We only need to calculate these once. Curves, append item. Okay. Then, I guess we will say, we will want to like find the bounds of each of these. So we can do something that's like curve bounds, which is going to take a glyph segment iterator output and return us a bounding box of some form. Maybe like parameterized, but maybe not. This is going to have like min x, probably an I64. I'm assuming. I don't really remember the types here, but I'm gonna use I64s for now, and we can kind of change our answer later if we feel like it. And for each of these things, we're going to say switch curve. If it's a line, we have a line. And if it's a curve, we have like, we have like points that we're gonna look at for each of these. Points bounds. So I think that we can kind of like say, given a slice of points, what is in these things? It's I-vec2s. We just say for points point. We keep track of all of these things. So this is going to be stud math max I64 for both of these, and then these ones are going to be min. Which isn't like stud num. Max int maybe. Yeah. And then I actually think that on min, we're going to be the negative max int. That's kind of more correct. So I think min int gives us 0. Yeah. Oh, no, wait, hold on. If signedness is unsigned, then it returns 0. Otherwise, it returns this. Wait, that is what I want. Okay. And this is actually wrong. This should be max int here and min int here. Okay. So for each point, we're just going to say if points 0, I guess we say like min x is equal to minimum of points 0 and min x. Min y is 1, and then we go min max. Okay, cool. And then we should be able to return this thing. Okay. Bing, bang, boom. Okay. So this is min, max x, y, and max y. Okay. All right. So now for the line, we can say return the points bounds of L.A, L.B, right, like this. And then if we have bezier of B, we can just call the same function, but with an extra point. Yep. Okay. So now we can say, we probably want to like have some sort of way to like merge these bounding boxes. Yep. Right. So we're saying like we have bounding boxes for many curves. What is the bounding box of all the curves? Right. And this is literally just like min a dot and b dot min x, like this, and then we have to like kind of make sure that everything is matched up. So max is the max, and then here we just replace x's with y's, I guess. Yep. So min, max, 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 min, max, max, max. Yep. Chillin'. Okay. So then we say like total b box is equal to can we actually just kind of do this off rip here and say like invalid or like yeah, invalid. I kind of like this. Yeah. Then we can say var ret is equal to invalid here. And then here we do ret dot and ret dot. And then we return ret. Because this makes it so that we can set our total b box as b box invalid, and then just merge b boxes of total b box and item b box, and then we just need to make the item b box is b box, what do we call it? Curve bounds of item. Okay, so now I believe at this point we have some form of bounding box for the entire object. Object b box. Let's see. I don't really remember why I was doing this, but I'm sure it'll come back to me in a minute. Fuck. This should be b box dot invalid like this. And then here I was doing negative minint like a fucking idiot. I don't know what the fuck I'm talking about. There we go. Okay. Yeah, so here we're getting bounding boxes for each item, which is pretty sick. And so that means that we should be able to iterate the canvas for each line. So for now, let's just say like, can we just renderer draw rect from total b box min x total b box max x total b box min y total bin box max y with like just draw it red or something, right? So now if we do let's only do one letter here because this is like annoying. Okay, so we'll do it like this. We'll say only give me the letter B, please. Okay, cool. So now we have a red box where the letter B would go, which is pretty cool. Pretty sick for us. Now we can like iterate that thing, right? So we can go for while y is less than total b box max y, var y is equal to total b box min y, defer y plus equals 1. Let's replace this draw rect with a draw line now. So for each row, we are just going to now draw a line with width 1. Oops. We do want to actually run our code, not just open this thing. He's mad because draw a line. Actually, we don't want to draw a line. We just want a memset here. So we want to look at the renderer canvas from. There's actually a renderer.row get row. Can we just make that public for now, so that I don't have to like. We're just violating abstraction. It's fine. It's fine. So we're gonna get the row for this y value. And then can we just say like memset row from I think there's like we use like clamped x and clamped y here to get us within the range. Yep. So renderer clamped x min to renderer clamped x max. And we memset this with our color. Okay. So if we do this, we should still see our red box, but instead he's mad because clamped x returns an I64, which is a little annoying. But it's fine. Okay, so now we refresh, we still see red, and then just to make sure that we're not like misdiagnosing, let's just change the color just to make sure. Yeah, okay, we're chilling. We are chilling. Okay. So now what we want to do is for each row, we basically want to find the we want a list of points where a curve intersects. I think that's what we want. So I think what that means is we're going to extract out our renderer, which is fine. Maybe we don't have to, because we'll just violate abstractions again. Fuck it. So we have find bezier t for y. We'll just kind of throw that in here. And we'll kind of say that like we want to say like row points, row curve points are equal to, let's think, we have find row curve points given curves items and our current y value. Is that it? It might be. Find row curve points. This is going to take in curves, which are glyph segment iter outputs, which is a little fucking weird. We should fix that name. And a y is an I64. And this is going to return some form of x points. Yes. Okay. So this needs an allocator as well. Font rendering is so complex. I thought it must be a simple task, which is obviously not true. Yeah, I think it's quite complex. I think we're barely starting to touch it too. I think we're like we're really only touching the tip of the iceberg right now. Okay, so here we're going to say, I guess we have some return, which is going to be an array list of I64. It's initialized their allocator. Later we nuke that thing, and we say for curves, we have some curve. And for each curve, we're going to say switch on the curve. If it's a line, I assume that this is easy. Bezier curve, we're going to call like renderer find bezier t for y, given our I think it's like this. So we take all the y points from the point in the Bezier curve, as well as the y point that we are at. And then we use these to sample this thing at the X positions. Like something like this, except we probably have to check if it's sane or not. So I guess we can probably just look at the renderer, and what do we do here? Here. So what the fuck are we doing here? We sample at our Y position as well as Y plus 1. Oh, right, because there we had this scenario where your curve might look like this, right? And so like if your Y value is here, you're going to find one X position that goes with this because you can find on like one sample point. But in reality, you kind of want to sample here and here. So we did some form of like Y plus 1. I guess we probably just want to copy almost all of this thing down and then just adjust it is probably more reasonable. Copy paste. Code by copy paste, everybody. This is what you should always do. And then it looks like we had some like float conversion stuff that we had to do because the things come in as integers, so sure. So we do this, we then get our t's, we skip anything where they're out of bounds, and then here we have our x range. Okay. But this feels kind of wrong to me. So instead of rendering something right now, we literally just put these points. We don't do any rendering right now. We just slap these things in our output. So x1 and x2. So what are these? Sorry, we gotta look at this again. So I'm like looking at this, right? And I guess I'm saying like, given a y position here and a y plus 1 of here, we're taking these 4 points and giving them to, yeah, we're calculating these 4 points. And really, we only just want like the outer 2. Yeah. Yeah. Or maybe we don't even care about this like double sampling anymore. Maybe we can kind of nuke this. And because now that we're kind of, we can just always work off like the left edge or something. I'm kind of down to try not doing this t plus 1 trick. I'm kind of curious to see what that does. So kind of like this. And so we just kind of round this shit and then slap that in our output, maybe? Seems kind of sane. Sure. Then for the line, what do we do here? We say that we have like LA1 and LB1. This is like the Y range of this line. So we say like if Y, I guess we're gonna like lerp the X values of this according to the Y value. So we're gonna have like Y minus L dot A1 to say this is my distance from A over the total distance of this thing. Yeah. And I think that we probably want floating point versions of these things again. Kind of just hand wavy. It feels like that's what I'm gonna want. So we go from y minus a to b minus a, I guess. Okay. And if t is in the right range, which we did with this before. If this is fine, then we just we do const x is a std math lerp of af0 af or bf0. Yep. So the two x coordinates, and lerp these by t, and then we just append that. Sure. That's reasonable. Sure. This thing needs to be yf. Maybe. And then I guess we will iterate over. This finds the row curve points. We just return ret to own slice, which means that this thing is going to be like defer alloc free row curve points. And I guess we just say like for 0 to row curve points line over 2, we kind of memset from row curve points I times 2 to row curve points I times 2 plus 1? Maybe? That's like a maybe. Seems possible. This thing can definitely fail. Fuck. Found expected IC4 find F32. So 717 here. We need to do a round of this thing as well. Okay. Fuck. Error unit is ignored. Down here. Okay. Let's try it again. And now he's mad at integer part of floating point value out of bounds at 717. So here we did something stupid. Oops. Inverted condition. This is mad because start index is larger than end index. So we forgot we have to sort these things. Stud, sort, mem, sort these I64s. And do we need to provide some sort of less than function? We do. Which should be pretty easy. Should be pretty easy. We just need to take this thing, slap it over here. Context is going to be void. And then these are going to be I64s, boom, boom. And then we just return LHS is less than RHS. Chill. All right. Let's see it. Oh, that's not bad. That's not bad. I don't know what's happening here. That seems bad. And it's also, I think, upside down. So we probably need to like flip it. Probably need to flip it. So before we were doing like flip Y thing offs. Sure. So flip Y, we were taking the height of the canvas probably. So here we probably want to use the height of the bounding box, I guess. I'm not sure. Not sure. So in our canvas, yeah, I guess we just take the height of canvas, I guess. So here we'll just call get row. Wherever the fuck we do this, we'll call flip Y here. Yeah. Like this. And then that will probably render it at the bottom. Fuck. Flip Y. Y is a IVEC2. Oh, sure. It's fine. We'll just do this. We'll do calc height minus Y. He's mad about something. Renderer clamp Y or something, or I guess we say if flipped Y is this, and if flipped Y is out of bounds. We have like a fucking problem. I'm surprised that this is only a problem when we flip, though. Oh well. If flipped Y is greater than renderer calc height, or equal to probably, or flipped Y is less than 0, continue. And then here we get row with flipped Y. Let's see what that does. Okay, that looks pretty good. And then can we just like offset this thing a little bit as well? Like, can we just like shove it like 50 up or something? Other way. There we go. Okay, cool. And then we got to figure out why some of these lines are missing. I kind of thought that this would work, to be honest. It means that like some of these, it looks like it's like on the start of a curve would be my guess here, right? My guess here is that this is like start of a curve. We're not identifying both sides of the line correctly. So maybe, can we just like print out maybe on each line what our list of points looks like? Points. What the fuck have we done wrong here? Skipping. Fuck this. We don't need that log. Okay. So I guess we want to do 2 and 1. It's fair for you. Thoughts on coders who are not driven by passion to learn, but the passion to earn? Do they make worse coders? I mean, it depends on how good they are. I think that like the two things are like unrelated almost. That's my guess. That's my take. That's my take. I think that like you could be good at what you do no matter what your motivations are, and you just have to find what motivations work well for you. But I would say it's probably like I am not motivated by earnings at all, so I have no desire to be that way. But you know, it's different for some people. It looks like here, I'm betting that this line is this line. I bet you we're going to see an occasional 5-element array here. And each of these 5-element arrays probably lines up with one of these, right? So we're seeing like can we check if we open this in another thing? When I interview candidates, I always hard pass on those without passion to learn. But like, how can you tell? Like, you can't tell if they have a passion to learn, or if they're faking a passion to learn, or if their passion to learn comes from a passion to make money, right? I think who cares what their motivations are as long as you can like use those motivations for whatever value you want to provide, right? I think like every company I've ever worked at, every company, the places I've worked, they want me to have a desire to make them money. right? That's like ultimately what they want. They want me to like, they put an emphasis on like, you should be going above and beyond to make people happy with the product so we make more money, right? But if that was actually what they were going, like, I don't have that in any way, shape, or form. Like, literally zero, right? But what I do have is I just want to make something that's good. And that happens to line up very well with what they actually want, right? And so, like, who cares? Who cares if, like, I actually, like, who cares what the motivations are, as long as you can get them to align with what you want, right? Like, so I think that, like, if you're like, this guy doesn't have a passion to learn, it's like, who cares if he has a passion to learn if he has a passion for something else that makes him learn well, you know? But I mean, also, like, what the fuck do I know? So this is at 650-ish. 650-ish, which is probably... Oh, maybe it's backwards? It probably is backwards, huh? I would have revised for capability and willingness to learn. There we go. I agree with that. It could be all the way back here, actually. If it's 604 and this is just like supposed to go all the way back here because each one of these is going farther, it could be like around here. Sure. So 608 kind of makes sense. 1065, does that kind of line up with over here? 1065 maybe on this side does. Yeah, here we go. It's down here. It's this line. So I think that makes sense. Now the question is what am I supposed to do here? Why is this doubled up? So here I'm seeing a Bezier curve. I would like to maybe log the curve that caused this as well. Oh, that's kind of hard. That's kind of hard. So this is saying that for a given curve, I found 2 points that are the same, right? Which means that I am not in the quadratic part, right? That's kind of what this is saying. It's saying that, like, if I'm like drawing this curve, I've hit this exact point where, which I thought meant that I should just have no effect. That's what I thought, but I guess there's another scenario maybe where we're kind of going like this. But then we kind of only get one of the two elements. Because there should be like a second t here at t equals like 1.5 or something that's like out of bounds, and we skip. So in what cases are we doubling up? That's the question we need to answer. That's the question we need to answer. So can we do like if, can we call this t's? If t0 equals t1, can we do this? Okay. So double up at 1. Double up at the end of the line, which seems kind of bad to me. So here we're doing like quadratic formula. We're saying, so my understanding was that shouldn't ever happen. Right? Like, because you have a curve here, you have point here, and like point here, right? So my understanding was that we should never double up at the end of the curve, but that's clearly not the case. So what am I missing here? So we have A, B, C. Oh, so the Y values for B and C are the exact same. Oh, that's interesting. So that's probably like one of these cases where you have like C here, A here, and like B is like aligned like this. I see. And so I guess in the case where they're the same, instead of double counting, we want to single count? That doesn't really make sense to me. I guess because could you also have this scenario where you have A, B, C? I don't think that's how this would look. I think that this would be A, B, A, C, B. Um, I think probably like you could use like the winding order of this thing to double count it going inside. But my gut kind of still lines up like how do I say this? I thought when I was thinking about this earlier that if I ever have a case where I have like 2 points of the same value, that has to be the peak of the curve. But I guess another Bezier curve is starting right after this, right? We're kind of doing this as well, which I guess should still have the same effect. I would like to maybe look at all the curves. That's annoying. um, yeah, it might be interesting to look at all like. It might be interesting to look at all of them. So can we just print them out? For curves. Um, can we say, let's look at these things. So, I guess we just want to like switch on the type of the curve, probably. And if we have like Bezier, we're going to do something. And if we have a line, we're going to do something else. So here we're going to be like, here is our line. Okay. And here is our curve. Okay. That's fucking annoying. I don't want it to look like that. So let's log these things a little better. D, 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 D. There we go. And this is LA and LB. And I guess now we can write any, because these are actually 2D points. We'll see how that looks. There we go. That looks a lot better. Okay. So we are fucking up at what is it? Key info locals. So we're at A, B, C. So we're at 104, 876.08. 608. Here. So we're at this line. And then who's adjacent to this thing? This thing, probably. So when we look at this, we're coming up from the bottom. We have a line that we are like looking at this line here that goes from 166. Oh, wait. Yeah. So 166 to 608. I guess it could be this guy here. This Bezier ends at y104, so probably y equals 0 is probably like here or something. It might be down here. Weird axes, but that's fine. We could maybe draw this one in a different color or something, but that's not really that easy. Okay. We're like pretty sure this is the one, right? 104, 870, 1004, 870, 608. 1004, 870, yeah, it's this. So we have a line, probably this one. It's gotta be, right? And then this curve. Now, this is doubling up because at the end of the curve, here is the tangent of this thing. I see. And just, okay. So the case is we have a line, then we are defining a curve with a point here, like a point up here, and a Bezier curve control point that is like something like this, directly on axis. Which means that this becomes the tangent of the quadratic right here. But even though this is the absolute like bottom out point, they still want the stuff over here to be colored in. That's what's happening. I'm pretty sure that's what's happening. Are you not just printing when t equals 0? I am. This is printing like the definition of the curve. And then the breakpoint is happening when when I'm doubling up on like the 2 points that it calculates are the same point. So I guess this just means that if I'm seeing the same point twice, if it's literally at the tangent, I want to use it. See, or like at the bottom of the curve, I should say. But how do I distinguish that from this case? Right? Those are the same case almost. In my mind, this feels wrong. I would have assumed that this is incorrect. That's crazy that they are expecting that if I hit the very, very, very bottom of this, such that there's only one root, they're like, that counts. That seems insane to me. Maybe you caught it already, but the t for y returns the duplicate when denominator I equals 0. Oh, yeah. No, but that's cool. I mean, I kind of did that on purpose. I did that on purpose because I think that means that you should go immediately in and out, right? If you're saying anything within this quadratic like is colored in, then if you double hit right here, then you should immediately go in and out. But I guess what's happening here is that because the point is at the edge of the definition, you have to account for what was beside it, I guess. Which is very interesting. Very interesting indeed. Right? Like, because in this scenario where you have like a line segment here and a bit and like half a quadratic here, it means that you don't immediately curve back. So I guess maybe we special case if we're on the edge. That could be it. That could be it. So maybe. I mean, that feels fucked to do that. But maybe it's the way. So if the t's are the same and they're at the bounds, we only pick one of them. I guess so. And we might be able to get away with like exact floating point math here, because zeros are and ones are perfectly representable in floats. What's like the math look like here? I guess there's definitely room for error here when we're just doing like fucking floating point quadratic formula. There's definitely room for error. So, what are our line points here again? Hold on. So the line at y equals 0, we have 1, 2, 3, 4, 5, 4 points. No, that's not true. 1, 2, 3, 4, 5. We because this guy double triggers. So hold on. Let's take the breakpoint out again. I want to look at the actual lines that come out, which I think we draw somewhere. So here we draw from 166 to 369. So each curve, yeah, it's something about like, they talk about like inside and outside of this thing, which maybe we could leverage. Right, we kind of know based off of the order, like the direction of the curve, if this thing is supposed to create a hole and a like masked off segment. So we could use that and say this 608 is double counted as like a go inside the mesh type shit. I just don't really know if that's what I want. Because like there's something about this that feels like a bug. I just like the fact that this is double counted feels wrong, but I can't rationalize why. Oh, it's because it's on the same fucking curve. Right, that's yeah, I guess I'm consistently getting confused about the fact that this case and this case are behaving differently. But it's not this case and this case. It's because our curves in this case, the curve is only half. And I wonder if that's always the case. The like negating the curve the double negative thing. It's not objectively the wrong way to write it. Shut the fuck up. I wrote it that way intentionally because nan math makes it so that if you get a nan, one of the ways that the condition is written will always return true, and one way will always return false. So I do the negative of it to make it so that the just when I hit a nan, that it goes into the path that I want. Because I like did some like division by infinity or something, you know, like just something fucking stupid. Wow, that's horrifying. Yeah, it is what it is. How many times do you guys think I can draw this line before I understand what I want to do? I really thought. I mean, I saw this concept come up when I watched Sebastian Logg's video on this. I just was so confident that I wouldn't hit it. So, yeah, it is. God, it's just this case. It's so obvious that when you go inside the thing, you don't want to come outside and still be on. It's so clear to me that's true in that case, and it's just so strange to me that we're hitting another case where that is not true. And I guess it's just because we're at the end of the line. So we could do something that says like, okay, yeah, because what happens if we have like two Bezier curves that line up like this, right? In that case, we see it 4 times, which again, I would think that we shouldn't trigger. It has something to do with the fact that there's a line coming in instead. And the line is completely aligned with this thing. Oh! Hold on. So here we end the line here, and then we start the line here again? No, I don't get it. I am down to try doing something that says like, if we're like literally just at the end of the curve, don't double count. I'm down to try that, but it doesn't feel right. It does not feel right. So my guess here says like, if t's it's also kind of interesting. I bet you there's another bug here where we can probably go slightly over. Like slightly, you know, if we have like a valid range of t's from 0 to 1, and like sometimes our quadratic formula might put us here because of like floating point imprecision, and we're probably not counting that either, which is probably bad. We could maybe clamp our outputs to 0 to 1. Although that doesn't make sense because we need to discard things that are out of bounds of the quadrat of the, like, if we are looking at this, all of these things need to go away, which is how we're kind of doing this right now. I think. Or I guess it's kind of like more of these ones. These are all going to have t values greater than 1 or less than 0. And we don't want to draw them. Fuck it. I guess we'll just try it. We'll say if t's 0 minus t's 1 is less than epsilon, and t's 1 minus 0, or t's 1, I guess if like we need like absolute values on here, and t's 1 is less than epsilon, or t1 minus 1.0 is less than epsilon, we'll say I don't know, we'll say that this is like, we seem to double count sorry, we should say like, in the case where we have a line segment followed by a quadratic, a Bezier curve, where the apex of the Bezier curve lines up perfectly with the end of the line segment. I guess we'll say handle the case where, oopsies. In this case, I would think that the Bezier curve should not be included as the apex of the quadratic essentially becomes a go in, then immediately go out. However, we only have half the curve. In this case, we only have half the curve, which means that the enter or exit is discarded, even though it is exactly the same point. That's kind of how I feel like I'm seeing it right here. And I think that's like a justifiable thing to say. And then we'll just say what? T's 1 is equal to 100. Set one of the T's out of bounds intentionally. Fuck. What's he pissed about? Is T's not 2 floats? It is. So here we have expected integer float or vector float found bool. Oh, I'm a dumbass. I have the bracket on the abs in the wrong spot. Here and here. All right, so what happened there? Fuck. We fixed exactly the one broken case. But not all of the other broken cases. That's so funny. That's so funny. Okay, let's look at the next one. I guess I should have seen that one coming. So we still have this double count case. And in these ones it's different. So then we can say down here, if t is 0 is equal to t is 1, breakpoint. Okay, so this is never happening anymore. So now we want to do if t's 0 is like minus t's 1 is less than some epsilon. So first we'll try that. So that doesn't trigger either. So what if we just like increase epsilon? Are we hitting that? No? Okay, so that means that we're probably seeing 2 curves line up with each other, right? Here, we're probably seeing at 817 that this is actually in 2 different curves. Aha! Aha, aha! So this is the same problem, but just like kind of framed very slightly differently. Right? This is now saying we're double counting this point because the ends of 2 lines are lining up with each other. They're directly on top. And so we shouldn't be counting that point twice. That's interesting. So that's actually the same problem, but just framed slightly differently, which means that we might be able to get rid of this hack, right? We're kind of saying that like here, because we are looking at exactly the joining point, this curve and this curve are both creating a point here to intersect with, which is a problem. I remember Sebastian Locke split all beziers at their turning points. That may have been part of his solution to this problem. Maybe. We almost want to like join them. So I wonder if we just if we just like ignore one end. We could do something that's like, if let's try something else. Let's try something else. Comment this out, and we'll say if this thing is just fucking close to 0, just fuck off. Because anything that is close to 0 will also be accounted for on another segment that's close to 1. Right? Because every single contour is a loop, you'll have like 0 to 1, 0 to 1, 0 to 1, right? 0 to 1. And so it kind of seems like if you just always ditched the 0 and only ever took it when it's 1, then you kind of solve this problem in both cases. Which means here we want to go like, if t minus eps is less than, or abs t is less than eps. You know, I guess here we don't have to do abs. Yeah. And we'll say discard beginning of every line segment because it will be accounted for at end of another line segment. Now, epsilon here is a little fucked, probably. If we're going pixel by pixel, we actually want to... Oh, that's kind of weird, right? Say you had, like, this case, right? Or you have, like, a line going like this to this. And then you kind of, like, start, like, pixelating this shit. Right? Like, all of this is in one pixel. Kind of like hand wavy. You almost... like... you almost want to size your epsilon relative to like the slope and the pixel size. That seems kind of fucked up. I actually think we want to use inside outsides. I think that that's like the right answer. So if you go into like here, somewhere, I thought it was in this one. Maybe it's in this one. They talk about like winding order somewhere. Maybe this one? No, this is definitely not it. This is like fucking assembly instructions. Maybe in here. Somewhere they talk about the fact that like clockwise and counterclockwise have different meanings. And maybe we just have to leverage this because of the fact that we're double counting. Instruction processing, interpret environment, how the font engine works, scan converting. Once the master outline has been scaled and grid fitted, it is ready to be rasterized by the scan converter. The scan converter takes the grid fitted outline and applies a set of rules to determine which pixels will be part of the glyph. If a pixel center falls within the glyph outline, the pixel is turned on. Distinguishing the inside from the outside of a glyph. A key problem facing the scan converter is determining what it means for a pixel center to fall within or on the glyph outline. Sometimes this may seem obvious, but complex glyphs make this seemingly straightforward question a difficult one. True type scan converter solves the problem by using non-zero winding number rule to distinguish the interior from the exterior of a glyph. The rule is as follows. Points that have a non-zero winding number are inside the glyph. All other points are outside the glyph. Draw a ray from the point in question towards infinity. Start counting with 0. Add 1. Wait, this is what I'm doing. Fuck! Add 1 to the count each time the glyph contour crosses a ray from right to left or top or bottom to top. Subtract 1 from the count each time contour. Fuck. But then... oh no, here, they talk about this again. Here, this is what I was looking for. An on-off transition is... okay, what is this? This is figure 7. Figure 7 demonstrates the use of winding numbers in determining whether a point is inside the glyph. Oh, did I miss something about it depends on like the cross product in some way. Add 1 to every time we cross the ray from right to left or bottom to top. This is what we're missing. From right to left or bottom to top. Right, so that's why this is okay. Because these are top to bottom. Sure. So we just have to calculate like the direction of the line essentially. And it's clockwise is inside, counterclockwise is outside. Is that right? So how, if we're walking right to left, yeah, here we see that this thing is up. Yeah. Okay. So that means we have to do like if L dot A, we only have to care about vertical because all of our scan lines are going horizontal, right? And so we're saying if L, I think our output here has to store whether we're inside or outside. That's kind of my guess here. So we'll have like, each point will say my position, and if we are entering, okay? So entering is going to be basically L dot A is less than L dot B. One. Now, what if we are like on the line? We're just ignoring that for now. Fuck it. I don't give a shit. And then here we append x pause is equal to this. And entering is equal to entering. Okay. What have I fucked up here? There. Okay. Then on this side, how do we determine? How do we determine? So if we have something like this, we have to know. Oh, geez. So that means we have to calculate the tangent of the curve wherever we are on the curve, right? That's kind of fucked up, right? So we have like A, B, A, C, and B. I guess we probably know. There's probably something about this line we can leverage. I think that there's something about like okay, let's think about like this case where we have like Bezier like this, where these line up. I assume that this looks something like this. I actually don't know. Huh. I don't know. Tangent of Bezier curve. Tangent quadratic Bezier curve. Okay, let's see. What does this guy say? This is the Bezier curve. Yep. And what is B2 here? B the first. Oh, this is 2 curves. I want 1 curve. Maybe the Wikipedia article will tell us. Oh, right. I guess we know from the definition of the Bezier curve. Yeah. So when we draw the Bezier curve, when we draw that motherfucker, we are saying we have a point here, a point here, and a point here, right? And the way this works is we lerp from here to here and here to here by some amount, right? So we go like 0.3 in on both, right? Then we go 0.3 in on this line, and that's the point on the curve that we're at, which means that this line is the tangent line. Which means that we know that this is perpendicular to the curve where we hit. Is that true? So if we're trying to find out if we're going in, I think you just need to determine the orientation of each contour and then apply each curve line to it. That's what I'm trying to do. I need to like the direction, the orientation. The problem here is that like one curve does not have like one orientation, right? If I cross here, we're going in, and we cross here, we're going out, which means that we have to determine like if the tangent line is like sloping down or up, essentially, right? Which is very doable, very doable. So here, when we sample quad Bezier curve, we can just be like pub function Bezier quad, Bezier tangent line. Yeah. And we will basically just do what we were already doing here. And I guess it's going to return 2. Tangent line. So like A is going to be some point. Is going to be some point. And B is going to be one of these as well. Okay. Yeah. And then we can just do this, just the first half of this, and then really we can kind of redefine this in terms of that. So we can say const tangent line is quad Bezier tangent line ABC T boom, and then we go tangent line A, tangent line B with splat of T again. Okay, and then here we just return A is equal to AB, B is equal to BC. Let's go. Okay, so now here we can say renderer quad Bezier tangent line of A, F, B, F, C, F, T. Okay. Sorry, this is wrong. T here. Yup. And now we can say entering is equal to the tangent line dot B y is greater than the tangent line A y. Right? Because that means that we are going. Oh, we want hold on. Which way is it? It's clockwise. So we're entering if B is greater than A, and we're exiting if B is less than A. Yeah. And then here we will what happens here? We append x pause is equal to x1 pix, and the entering is equal to entering. Okay, so now what we have to do is we have to discard any elements if there's double entering. But first, can we just like build this and see what happens? Because I think that what we should see now is we should see something that's like at least reasonable when we log the positions. Um, like this. This is row curve point. This is row curve point, and then this thing needs. Okay, X pause here and here. This won't fix the bug, but it should at least get us compiling into the same state we were in before. And so now we should be able to find wherever our like 608 shit was. I guess we won't. Fuck. Yeah, so here our double 608 says both of these are exiting, which seems good. True, false, true, false. Yeah. So points here we have true, false, true. Ow, my head. True, false, true, false. Nice. And then in the cases where it's fucked up, we have true, false, 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 false. So here we have just like a bunch of shit where they don't want any of these logged, which means that that's probably wrong, right? Seems likely wrong. Seems likely wrong. But we can easily check this now if we do like var I equals 0 while I is less than row curve points len. Defer I plus equals 1. This is a usize. And now we can only draw if from segments of entering to exiting. So here we'll say like const start is row curve points at I. And then while we want to like advance until we see entering is false, right? So here we're gonna like assert start that we were like entering. So then we're gonna say like while I is less than row curve points len. Probably we just do this in here and we say like yeah, if row curve points I entering feel false, break I plus equals 1. And then here we should have like if I is less than row curve points is greater than or equal to row curve points dot len, we break. And then we say const end is equal to row curve points I here, nice, and then assert end entering is equal to false. Which means that this is wrong, actually. We kind of want to, like, then... We want to advance until we see entering, then advance till we see exiting, and then we kind of flip-flop between them. That seems reasonable to me. So... While row curve point I is less than row curve points dot len, and row curve points I dot entering is equal to false, we I plus equals 1. Then we have the start. Then we have when we keep going until we see false. And I guess here we just kind of do the same thing as we did up here. Like this. Yep. Then we can do start entering is true and end entering is false. And then we can go from start xpause to end xpause. Okay. Let's see what that does. Presumably nothing good. End index out of bounds at 8:30. Yeah, okay. So I guess here it's hitting a case where we're like angry. So we'll just put another check here. And then can we not run GDB? We're not. Okay. Let's just see what happens. Okay. Refresh. So that actually fixed a lot of them. But it actually did not fix this one. So this is back to the cases where the a line and a quad are like hitting each other. And there's probably just like a less than or equal to thing. So entering here, we did A is less than B. And entering, we did again, A is less than B. Which is fine. And then I guess we'll bring back this hack. I suspect that this is wrong, but I want to know if this at least fixes the problem. It does not. Ooh, interesting. We could consider throwing in a less than or equal to here. Although I don't believe that should fix the problem, but maybe it does. Oh? Oh? Okay. So maybe a slope of 0 counts. I mean, that seems to be working. Seems to be working. Let's run for all letters of the alphabet and see if they're all shit. Hey. Hey. Fuck. No! Interesting. Okay, so the rest of these look okay so far. Okay, so it's in A and K we have the same case here, where we have two lines that are like running into each other at a diagonal like this. And I think that maybe we just need to fix the sort order. I bet that on the letter A, we have the right elements, just not in the right order. That would be my bet here. So can we go back to only doing one letter? Let's do the letter A and see if we can find this point. So, oh god, dude. I can't read this. Are you kidding me? Function format. How do we make a formatter again? Stood debug format. Print, I mean. Goes into print, which goes into print, which goes into format here. Paint app pause? Yeah, that's not a bad idea. That's not an awful idea, is it? Open with color paint. So we're at, oh fuck. If I fucking middle click here, it doesn't drag. This is at like 615, 616 inch, 684. So we want, oh, but the Y is flipped. So can we do like 615? This is not great. Okay, let's just try to log these things a little bit better. this will make it much easier for us. Much easier. So fuck this noise, and we're just gonna like writer print. And we're gonna look at this, maybe with Boolean in brackets. Okay, and then we say value x pause, value entering. Let's see if that's any better. He's mad about what? Invalid type B for bool? What am I supposed to do for bool? D? Nothing? There we go. Okay, that's much easier to read. Okay, so there's going to be one case. We're looking for like one case towards, I think we're drawing this thing bottom to top. So it's going to be towards the end of the whole thing. Right, so here, every time we see true, false, we're kind of like in this segment here. So as soon as we jump into 4 here, this is what I was talking about, dude. So we're seeing that we enter, exit, exit, instead of enter, exit, enter, exit. So I think that we just want to sort so that the falses show up before the trues. That's kind of my guess here. I'm not 100% sure that that will fix everything, but it seems reasonable if I don't think about it at all. And we don't think around here, so like maybe. Are you using the winding numbers? I think so. We are using if the tangent line to the Bezier is going up or if the line is going up. So we're using like, I think that's what a winding number is. Oh, we actually might not be using the you're kind of right, huh? So you're saying that when we exit, we have to count. That's a much better point. That's a much better answer than what I was going to do. That is a much better answer than what I was going to do. Because they did say that in the spec and I just forgot or didn't think about it or something. So instead of us going like, right now, we're saying like we have true, false, false, right? What the winding number thing says is that we should be counting how many trues we have and then not exiting until we have that many falses on the other side. Which makes sense. So how do we do that? This code sucks. So we want to iterate over I think this is going to be easier if we do the count as an I64. And we're going to iterate over the points for row curve points. And I think what we're just going to do is we're going to stash the start, right? And we're going to go for each point. For each point we go, if point dot entering is false, winding count minus equals 1. Yes. Else we add 1. Okay. If winding count is equal to 0 now, we draw from the start to wherever the fuck we are now. End is just point.x pause, right? If the winding count is 1, you can just use even odd rule now, right? Is that better? What do they say we're supposed to do? I'm pretty sure that you should giving a 0 winding number, exterior, their interior points non-zero. I think this is right. I think that's kind of what they say. It's what makes sense to me right now, so I'm just gonna do it that way, and it might be fucking stupid. That seems reasonable. So we say if we are we like update the winding count. We say if it's 0, we're donezo. I guess also we only want to draw if the winding count is 0 and we are exiting. Otherwise, we like had a false first, which is fucked up, which kind of indicates that the falses need to come second, like on tie breaks. I think that that's true. So here we'll go like if lhs.xpos equal to rhs.xpos, we return the smaller one. So left hand is less than right hand if left hand is false. Right, so we do this, I think, which means that here we'll always see false first. And we'll just put a note here, always see false first, which is actually wrong. We always want to see true first. So we need to flip that condition. So I guess we want like LHS entering and not RHS entering. That's less. That means that left is lower. So we should always see true first. Versus due to sorting. Okay, let's see if that fixes RA. Fuck. What happened here? What happened here? So we went true, true, false, false. So we went from 440 to 793. That seems reasonable to me. Where's the hole coming from? Where's the hole coming from? Am I stupid? I felt like that made a lot of sense. I'm not gonna lie. Not going to lie. It felt so reasonable to me. It felt... What did I do wrong? So first of all, this is a 2 pixel gap, right? Which lines up with this. But what I don't understand is why. What's even more confusing we only want to stash the XPOS if we are on the way in. Yeah. Otherwise, we're kind of updating the start point on the way. There we go, much better. So what's happening here is every time we saw an entering, every time we crossed a upwards line, we were resetting the start point when we should have only updated it when we first saw it. Which I think makes sense. I think that makes sense. So let's try rendering all characters again. And let's see what we get. Fuck! Fuck! Wait, didn't we fix this? No! We fixed that. We fixed it. We already What the fuck did we how? How, man? Okay. Dude, I swear we fucking fixed this. So here we're getting 166. Okay, let's open Paint because I want to look at the fucking points. So we're seeing 166 to 369. So that's here, 369 and 166 is probably over here, right? Yeah. So 166 to 369 is like, oh god, this segment here. Then we have nothing until we get to 604, which is here, to, oh, wait, hold on. We only exit once now. Oh, that's kind of fun. That's kind of fun. So now we're back to the double count bullshit. Right, where we enter this thing twice and we only exit it once. Which means that we might want to bring back this hack that says if we're on the edge, only consider one of us. Right? This was the thing where we were saying where if we have a point that's like a joiner between two lines, we end up counting it twice when we shouldn't. So here we're saying if we're at like fucking 0, like the very left edge of something, fuck off, don't use it. So that's here. If t is less than epsilon, continue. Okay. Moment of truth. F5? Oh, really? It doesn't... Ooh, that's kind of weird. Really? I thought that would fix it for sure. So now we're seeing... Oh, now this one's fixed again? Now these ones are broken up here. Let's go. Am I confused? The t for y's returns duplicate, but we're actually a linear equation with that answer. We are a quadratic equation with two answers. Is why? Because if you are a Bezier curve, and you are like, right, this is like one set of 3 points, and you go through here, there are two answers. That's why it's returning 2. And then what's happening is we are at the border of two curves, right? So we're kind of like here and here. So we have like one Bezier defined by this and one Bezier defined by this. And this point is going to count it twice because it's on two curves. Which I can't believe that fixed that one, but not this one. So what's happening here now? True, false, 817. That's got to be there, right? Open with color paint. This is 858. We're looking at like, this is like supposed to be 858 to 1102-ish. So coming from bottom to top, we're looking for like somewhere around 858 here. Where the fuck is the 21102? The fuck? Am I stupid? Hold on. Can we do 2 and 1 less? 858. Oh, here we go. Here we go. Hold on. So this is the case here, where we're getting a double true here. Double true. And so here, I guess we want to see in where we are seeing 859 double true. 859 double true. So these are probably both Bezier curves, right? We're probably seeing a curve on curve boundary. Oh, maybe not. If this is a line on curve boundary, what the fuck is this case? This is the wrong thing. That's probably what this was. I think we just kind of want this. I think my brain just wasn't all the way on. I think I just did the wrong hack. Nope. What was it? It was 858 to 1. No, wait, that seems right. Oh, wait, I didn't refresh. Now that I've refreshed, we're fucking back at the other one. So we need both hacks. We need both hacks. What is this one for? Handle the case where you have a line segment followed by a Bezier curve where the apex of the Bezier curve lines up perfect with the end of the line segment. In this case, I would think that the Bezier curve should not be included as the apex of the quad essentially becomes a go and then immediately go out. However, in this case, we only have half the curve, which means that the other enter or exit is discarded. Yeah, okay. You know what? That's a reasonable hack as well, now that I read it again. Nope, that doesn't fix it, huh? Does not fix it. It's also weird that sometimes... I'm actually not convinced. It seems like the refresh is, like, inconsistent. Yeah, it is. Which means that we're drawing incorrect conclusions. That's annoying. Okay. Reading on this, I feel like even odd would be way more appropriate and less of a headache for this use case. Okay, yeah, maybe I'm misunderstanding then. We could try even odd instead of 0. We could try that. So what's the even odd rule say? P3 goes transition followed by an odd off transition, has a 0 winding number, is on the other hand, it goes through an off transition followed by a second off transition giving a winding number of 2. It is an interior point. Am I... So... Okay. Let's read this again. 4 steps presented below constitute a method for determining the winding number of a point. Draw a ray from the point to position towards infinity, starting with a count of 0. Add 1 to the count each time the glyph crosses from right to left or bottom to top. Oh, we're doing left to right or top to... I think that's right. Sure, whatever. Subtract 1 from the count each time we go the other way. If the final count is non-zero, the point is interior point, otherwise it's exterior. So that's what we were doing. But then you guys are saying even odd. So does that explain, does this talk about this down here? An off transition shows figure 6. Okay, here we go. Demonstrates the use of winding numbers in determining whether a point is inside a glyph. Considering each of the points in questions, the following can be said. Points 1 and P4, 1 and 4 undergo a single transition then given them non-zero winding numbers. They are interior points. Yes. Point 2 goes under an off transition followed by an on transition, giving it a 0 winding number. It is exterior. Okay. P3 and P5 illustrate the importance of determining curve directions. Yep. Yeah, it seems like they're kind of saying off, like winding number 0 is the way to go. So what am I missing? It's the double counting that's fucking us, right? We have either double counting on a line quad boundary or a line boundary. And so in this scenario, what does our code base look like right now? Right now, we are discarding basically anything that is on the very, very, very left edge of a point, of a line. We're saying fuck that shit. Which means that we're probably erroring out around here somewhere where we have true, 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 false. Oh. Because here, we have discarded the 0 point here. Right, so we go 0 to 604. And then we're double counting the 604, which seems bad. because we're getting the same t value twice. Which means that the curve is going this way, clockwise. This is a hole, so it should be going counterclockwise. Yeah, so it's here to here. Then shouldn't the 604 be like part, like the left-hand side? Hold on, my brain. I believe what we're seeing is we're seeing. Give me the paintbrush. I think we're going from here to here. Here, this is like part of this line, right? Boom, 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 boom. So we're saying this line's going up, so we are entering here, chilling. Then we are seeing this line going from here to here. And we are saying if we're at the very left edge of the line, ignore that shit because we think that we're going to be double counted when we are on the top end of this line. Right? So why aren't we seeing that? I think that's the interesting part to look at here. Probably because our ranges are fucked up, would be my guess here. My guess is that we have a less than or equal to on one end and not the other end. So we can get there. It's find row curve points. Can we discarding x fuck. Discarding point at y this t is this. All right, let's see what's going on there. So we know that we're looking for this, right? 166, 604, 604, 1042. And this is not really that helpful to us, huh? Fuck. We almost want like the X position here too. What's he pissed about? We want to log the X value here. Okay, let's look for it again. Scrolling. Here we go. So we're looking for something discarded at like around 360, which we're not seeing. So that's kind of interesting. Oh, here, wait. Discarding point at 369. T is equal to negative 1.12. Okay. Why? That's interesting. That is interesting. Because I would think here that we should have a line that goes from here to here. I'm just joining the stream. I don't think it'll help for masterization, but you might want to do something different. You will probably want to do something different and better. Probably not better. But I have a similar project and parts of it might be useful. Not in the best condition, but I'm going to do more work on it soon. Thanks, man. But I think that I don't want to look at other implementations. It's kind of takes away from the fun, you know? So somewhere we should have a line that goes from approximately 369, 1200. Oh, fuck, the Y values are inverted. Fuck. But we can figure it out. So 369 here to 608. We're going 369 to like 604 over here. Ah, oh, god damn it. $369 here. These are the ones. So it's probably... Can we say discarding point online? We can probably just say what line we're on. Yeah, that makes more sense. Discarding point on line any to any. T is this. Yes. Okay, let's try that. Let's see if that gives me the information I'm looking for. So just scrolling up, looking for where we move from points of vector size 2 to points of vector size 4. Here we go. So it's here. This is the one. Right? So discarding point on line with 369, 713 to 166. Can we actually, let's just fucking stop flipping the fucking thing. That will make everything way easier to diagnose. Let's just not fucking flip that shit. I don't know why. Like, we're just making our own lives harder. Just fuck flip Y. Because now all the points will just line up exactly. I don't know what the fuck I'm talking about. Refresh. Refresh. Okay, here we go. So this is the thing. And now we are looking for... $369. Oh my god, wait, hold on. That's funny. Flipping it, I think... Did that change something? I'm not sure. Okay. Yeah, because clockwise and counterclockwise have switched now, which is kind of fucked. That's very strange. I have to think about that. But now we want to start top to bottom. Let's just look at the first broken thing. So the first broken thing is here. So that's not a trivial point to find, I feel like. Oh, I guess we know the points though. So this is a Y value of 713-ish. So maybe we log the Y value, then we can search for it. Y is this. Okay, Y 713. Okay. So this is another one of these true, 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 false cases. Nice. And so here, they discarded on the line of 369 to 1327. So, oh, sorry, 369, 1327 to 369, 877. Which makes sense. That's down here. We should be discarding that line. So that's good. Then why did this get discarded? So here, we're going big number to small number. So this is probably discarding the point because it's at 0. Which makes sense, right? Here we are probably seeing that that point is discarded because of that other trick for my next trick. Here. So we're discarding point on this line, and we'll say t close to 0. Okay. So now we're looking for y is, what was this again? 714? Yeah, so we're seeing this, t close to 0, which means that we are so that means that we have, fuck, hold on. We have this line, which is getting discarded because it's 0. And then there's this line where we're probably handling these two lines the same. That's probably our mistake. We also want to discard, so we want to discard if we cross, not discard, we want entering and exiting. We want this to be an enter and this to be an exit, I guess. That's my new hypothesis. So here we are entering if A is less than B on Y, or the A Y is equal to the BY and A0 is less than B0? Oopsies. No, that did jack shit, huh? God damn it, dude. Flip it? No, so that seems to be irrelevant. Can we look again? So this is 712 ish. So 166. We're going. Is this a 2 pixel fuck up here? No, this is a 1 pixel fuck up as far as I can tell. At Y 713. So it's this. So we're going 166 to 369. True to false. Why does this look like this then? Oh my god, I'm having trouble keeping track of my state. Hold on. Hold on. I think let's do here. I think this is where we want it to be. Okay, we refresh, open with color paint so that we can look at where this line is. This is Y equals 713. And here we are seeing 166 to 608, true. Oh, hold on. I see what's happening. Okay, wait, I understand. I think I understand. We have a case where we have this arrow, followed by this, essentially, right? Essentially this curve. So what's happening is we're going enter. Oh, and then also this has this as well, right? It's actually kind of the other way, sorry. It's this, and this, right? We're going along like essentially this line like this. And we were saying before that we really wanted to avoid double counting points, right? Which means that this point we discard on the up arrow. Okay? But it still exists on the left arrow, right? But we are not counting that one for some reason. Why aren't we counting that one? We are counting neither of them. They should both be line segments, so we should be able to figure out why it's killing both. So we're looking for something at 369. So one is that the t is close to 0, and one is that t is infinity. I bet you we're fucking up anything with horizontal lines. Yes, because we are dividing by the y value for both these. So if bf1 is equal to af1, we need to do something special. I don't know what yet. Else this. If it is horizontal, how do we determine a sane t value? We want to capture, probably we want to capture 1.0. Well, okay, let's think about this. So we have this same problem where if we're like this, we will count on this, on the vertical one. I think we can just pick one. I think that we can just do this. Would integer comparison be better here? Probably, right? I agree. And then I suspect that that doesn't fully solve it, but I'd be interested to see in what happens now. Okay. Oops, this is not the right thing. That's very surprising. I wouldn't have thought that that had any effect. What the fuck? Let me just make sure that that is in fact what happened. Flip it? Oh. Yeah, true. Oh, wait, no. If these are the same, then this subtraction will be 0. Am I stupid? Am I stupid? So everything else should be fine? I mean, clearly I'm wrong, but I don't understand why. Yeah, I mean, that's obviously wrong too. So why is this different? Shouldn't this horizontal line case be like almost none of them? Why is this happening all the fucking time? What the fuck am I missing? T value here. I would have thought that this has like almost no effect. So if the two y values are equivalent, let me just make sure that I'm not stupid. Let's just put them in both scenarios. Okay, yeah, so that works fine somehow. That also works fine. It's if I write 1.0 here, it falls over. Surprising. What's the difference? Because again, I would think that these lines are very rare. these completely horizontal lines. Here we're saying, okay, we see 166, 168, 369, 369, 604, 608, 608. Here's what's happening on most lines now when we do this 1.0 on a completely horizontal line. Can we do something like, let's just see what we're getting. Break block this, and then can we say like std debug print flat line any to any. L.A.L.B. Okay. So flat line oh, I'm a dumbass. It's because on every single scan line, we're not filtering out anymore if the thing is out of bounds. Yeah, I'm just a dumbass. Right, because the part where we filter out if it's like within the bounds is down here. So here we have to do like if these are the same, and y is equal to L.B1. Yeah. Oops. Just slight mistake there. We only want to do this in the case where we're actually on the correct line. There we go. There we go. Okay, so now we're back to this thing being broken as shit. So we want to look at 713, I think, was it? 713, yeah. Okay, so now this is looking better, right? In that we have both 166 and 369 now. But 369 is true. Right, because like we said earlier and we took back out, we need to do on a horizontal line, we want to check if it's facing right or left. So it's entering if it's facing to the right. So we want to, and L.A0 is less than L.B0. I think that's what we want. Okay. Okay, so that's one down. We fixed half of this broken line. And now we can go back to 713 again. And now the second half is fucked up. So we're double counting the 608 again. Which was this hack? But I suspect that if we do this, we're gonna start hitting other bugs again. Yeah. I don't think we like this hack. I think this hack is bad. So what is happening? We are double counting an entry because of what? Let's draw it out again. It's this. Right? So we are double counting this point. Oh, because yeah, why are we double counting that? That's actually surprising to me. So 608 is part of which curves? Somewhere we log the curves. Okay, so here are our curves. So we have 608 to 166 as well as curve one that ends on 608 here. I mean, it's this is the case, right? 608, 870, 1004 to 608 to 166. Right? No, it's something 369. This is supposed to be 369 here, if I remember correctly. What am I trying to do? Open with color paint. This is, yeah, 369 here, and this is, okay. Curves. Where are our curve list? So I think that we have one line that's going to the left towards 369. Here. And then a curve here that ends at 608. Uh-huh. So that's 608, 713, 608, 713. And we're double counting this 608. That's the only explanation. So why though? Because my understanding was that we should be kind of saying like, okay, t is less than epsilon. So we're discarding this point. And then we also have the t is less than epsilon check here. If x1 pix is equal to 608, can we like std debug print 608t is this value? Like, what am I missing? Y at 713. 608t value of 1. Oh, because we're double counting it again. Right, of course. So this, but like adjusting for that case breaks scan lines everywhere else. So what is this saying? If these things are close together and one of them is 0 or one of them is close to 1, discard 1. That seems fucking reasonable to me. But when we do that, maybe we look at what bug this brings back and see if there's like something else that we should be doing to fight whatever's breaking there, right? Because now we have all these other broken cases. This is fun. This is really fun. So I guess we want to figure out what line to look at here. So we're looking at line 104, I think. And here it's literally just that there's 1 point. Because wait, where'd it go? There we go. Because what? Yeah, I'm actually kind of confused here. How come we're discarding both now? I would think that we should only discard 1, right? Unless this case is wrong. If our two... Oh, I guess, it's only a problem if they're both double entering or double exiting. Which is also fucking weird. I hate everything, man. Yeah, there's something fucked up going on there. It's like if we enter and exit, we want to count both. but if we're double entering, we don't. All right, I don't know, man. I think we're close. I understand now that this is a fucking shit show. But that's looking pretty good. We have a I have to think about this because I don't think I'm going to solve this right now. We're already over time. But yeah, there's something. I'm doing something stupid here. We're close though. So we're gonna call it there. Thanks for watching, guys. I hope you enjoyed what you saw. I know that we did not quite get where I wanted to get to, but we did discover why font rendering is hard, which is kind of fun. Hopefully, I'll have a better answer for this tomorrow. If not, we can just slam our faces into the desk a few times and figure it out from there. Thanks for watching. We'll be back tomorrow at around 12:30 Pacific time to 4 o'clock Pacific time. It's 4:30 now, so if you're watching live, anywhere between 4 hours ago and now is when you should expect to see us live. If you're watching on YouTube, swing by on Twitch if you want to say hi, or if you want to see VODs for the 12:30 to 2 segment where we work on kind of like less new features and more cleanup-y type shit. You can check out the Patreon or the YouTube member section. There's extra stuff there if you want to see it, but if not, no big deal. If you're on Twitch, there's a YouTube link in the Twitch description where you can see previous work. So the VODs will end up under the font playlist here at probably soon. And there's a GitHub link in the Twitch description where these code will end up under the font render repo eventually. I think that's it. YouTube, peace out. Twitch, let's find someone to raid.